Welcome to the fifth lecture of the NCERT Simplified series for class 10th. Today we are going to discuss the second chapter of chemistry, which is acids, bases and salts. This is a small chapter which deals with basically three topics. First is regarding acids, second is regarding bases, and third is related to salts. So let's start with the first topic, that is acids. So this topic has been a part of the chemistry syllabus since class 6th, right? So we have studied various definitions for acids, bases and salts. So in the previous classes we have discovered that acids are substances which have a sour taste and bases are those substances which have a bitter taste and are soapy to touch. So here we can see the list of certain acids which we can find in our day-to-day life. First one is the tartaric acid. Now this tartaric acid can be seen in grapes, tamarind as well as unripe mango, and it is important for the sour taste in these fruits and vegetables. Lactic acid is seen in the sour milk as well as in the curd. Formic acid is the main component of the ant sting. Ascorbic acid is present in citrus fruits as well as amla, and ascorbic acid is nothing but vitamin C. Acetic acid is the major component of vinegar. Tannic acid is present in tea. Citric acid is present in citrus fruits like the orange and lemon. Oxalic acid is seen in spinach. Malic acid is seen in apple, and in our stomach also there is an acid which is the hydrochloric acid. So these are the various acids which are present around us. So now let us go for a classification of acids. Acids can be classified on the basis of various means. First, it can be classified on the basis of the constituents. Second, it can be classified on the basis of dilution. And third, on the basis of strength. On the basis of the constituents or origin, it can be classified into two types. If the acid is extracted from a plant or an animal, it is known as organic acid. Whereas those acids which are present from the earth's crust, they are known as inorganic acids. Now talking about dilution, there are two types of acids. One is known as concentrated acids and another is known as dilute acid. Concentrated acid means if you take the aqueous solution of that particular acid, the concentration of the acid will be more as compared to the concentration of water. If the concentration of water is more than the concentration of acid, then it is known as the dilute acid. So in concentrated, the concentration of acid is more, and in dilute, the concentration of water is more. Now what is strong acid? Strong acid is that which has high concentration of H plus ions, and weak acids are those which have low concentration of H plus ions. So now let us look at some chemical properties of acids. Now talking about the physical properties, it's just that it have a sour taste, it's a good conductor of electricity and so on. Now let us look at the chemical properties of acids, and this is important from examination point of view. First one, what happens when you put some acid on a metal? So let us take an example. We are putting a little bit of hydrochloric acid into a test tube containing some magnesium in it. So what is happening over here is that there is a reaction that is happening that results in the formation of salt, and you can also see a popping coming out. Some popping bubbles are coming out, and that bubbles are due to the hydrogen gas. So the gas which is liberated when an acid reacts with a metal is hydrogen gas, and along with the formation of this hydrogen gas there is formation of a salt. So in the case of magnesium, there is formation of a salt, that is magnesium chloride. Similarly, if you are reacting aluminium with HCl, then it results in the formation of a salt which is known as aluminium chloride, AlCl3, and also there is release of hydrogen gas. So with any metal we can say that it will releases hydrogen gas, and also there is formation of a salt. Similarly, if you take zinc is going to form ZnCl2. And if I am changing the acid to sulfuric acid, suppose like H2SO4, then it is going to form ZnSO4 as the salt along with the generation of hydrogen gas. So now let us look at the second case. Second case is explaining about the action of metal oxides. So metal oxides, that is generally written in the form MXOY, where M is the metal and O stands for oxygen. So this metal oxide, when it is reacted with acid, it results in the formation of a salt and also formation of water. That means if I write a general equation, it looks something like this. So I'll just highlight it. This is the equation that we are getting. Metal oxide plus acid gives salt plus water. In previous classes, we have studied about neutralization reactions. Neutralization reaction is a reaction in which an acid reacts with a base to form salt and water. So here you can see an acid, here you can see salt, and here you can see water. So this metal oxide is nothing but a base. So we can conclude that metal oxides are basic in nature. Now what about the non-metallic oxides? Like what about carbon dioxide? What about sulfur dioxide? Are they acidic or are they basic? These are non-metallic oxides, so they are acidic in nature. Whereas Na2O, MgO, etc. These are basic in nature. There are some exceptional cases like the aluminium oxide, which is amphoteric in nature. That is, it can react with acid as well as base. That we will be discussing in the next chapter, that is metals and nonmetals. So as of now, we have to study this general equation. That is, when a metal oxide is reacted with an acid, it results in the formation of a corresponding salt, and also there is formation of water. So from this is same as that of neutralization reaction. So from that we can conclude that metal oxides are basic in nature. Next one, we are going to study about the action of metal hydroxides. When metal hydroxides are acting with acid, when it is reacted with acids, it results in the formation of salt as well as it results in the formation of water. So this is again similar to our previous case. It is similar to the neutralization reaction once again. So here also we can conclude that here the metal hydroxide is going to act as the base. So we have seen two cases. Metal oxides are basic in nature, and now metal hydroxides are also basic in nature. Action with metal carbonates and bicarbonate. When a metal carbonate, that is MCO3, general representation is MCO3, so when that is reacting with an acid, it results in the formation of a salt, water and carbon dioxide. Similarly, magnesium or any other metal hydrogen carbonates, when treated with acid, gives salt, water and carbon dioxide. So general reaction is metal carbonate or metal hydrogen carbonate reacted with acid gives salt, water and carbon dioxide. So now let us take an example to understand this. Let us take magnesium. So if I talk about magnesium carbonate, when it is treated with hydrochloric acid, it results in the formation of magnesium chloride plus H2O plus CO2, that is carbon dioxide gas. So this carbon dioxide gas is going to come out from the test tube in the form of brisk effervescence. That is, some bubbles will be formed in the test tube, and that bubbles indicates that carbon dioxide gas is coming out. So this is also used as a test for distinguishing whether magnesium carbonate is present or not, or carbonate is present or not, because carbonate will releases CO2 when treated with an acid. Any carbonates when treated with an acid releases CO2. So this is used as a test of distinction for carbonate anions. So now we have finished the basic chemical properties of acids. So here I have a flowchart showing all these chemical properties. Acids when treated with metals results in the formation of salt and hydrogen. Acids plus metal oxides gives salt plus water. Acid plus metal hydroxide will give salt plus water. With base also it will give salt plus water. With carbonates and metal bicarbonates it will form salt plus water plus carbon dioxide. So now let us look at some of the important uses of acids. So talking about the uses of acid, first one is that it can be used in cars as well as inverters, and that is nothing but sulfuric acid. Second, it is used in the manufacture of synthetic fibers as well as plastics. Third, it is used in the preparation of dyes, detergents, glucose, fertilizers, etc. It is used for the descaling of pipes and cleaning metal surfaces, and it can also be used for the flavoring agent in food, such as the acetic acid or vinegar. It can also be used as a preservative in food for preserving the food for a longer duration. Now talking about the bases. Bases are bitter in taste and they are soapy to touch. Some of the common bases which we can see around us includes sodium hydroxide, that is seen in soaps, calcium hydroxides which is seen in lime water, potassium hydroxide which is seen in soap again, ammonium hydroxide which is seen in window cleansers, and magnesium hydroxides are seen in milk of magnesia, which is an antacid. Antacids are substances, so they are medicines which are used to cure acidity in our stomach. So now the formula of these compounds should be very clear. If you are still having a confusion regarding how to write the formula of chemical species, you can check the description box. I have put the link of the previous lecture where we have discussed about writing the formulas of these chemical species. So here we can see first one is sodium hydroxide. So sodium hydroxide, the formula is NaOH. Calcium hydroxide, calcium is having a valency of +2, so the formula is CaOH twice. Potassium hydroxide, potassium is having a charge of +1, so it is KOH. Ammonium hydroxide is NH4OH, and magnesium hydroxide, you can see MgOH twice. So what can you conclude from here? You can conclude that the anionic part is the same, that is OH. So we can say that if a particular compound is having OH in its formula, then probably that could be a base. Now, coming to the classification of bases, bases can be classified on the basis of concentration of H plus ions as well as on the basis of strength. On the basis of the concentration of H plus ions, it can be of two types. First one is known as dilute, where the concentration of base is less as compared to that of water, and concentrated if the concentration of base is more than that of water. Now, based on the strength, it can be divided into two. One is known as strong acids, where the concentration of OH negative ions are more, and weak if the concentration of OH negative ions are less. Now talking about the physical properties of bases, they are having a bitter taste, they are soluble, and if they are soluble, they are good conductors of electricity because of the movement of ions. They are soapy liquids, and caustic alkalis. Caustic alkalis such as NaOH and KOH, they are highly corrosive in nature. So these are the basic physical properties of bases. Next, we are going to talk about the chemical reactions of bases. So when a base is reacting with a metal, it results in the formation of salt and hydrogen, the same reaction as expected from an acid. So here we have an example. Zinc, when it is treated with NaOH, it results in the formation of a salt, that is sodium zincate. Formula for sodium zincate is Na2ZnO2 plus hydrogen gas is also coming out. Next is the action with acids. So with acids, it is known as neutralization reaction, and neutralization reaction results in the formation of salt as well as water. So an example is this one, NaOH when treated with H3PO4. This is known as phosphoric acid. So it results in the formation of a salt, which is sodium phosphate and water. So the formula of sodium phosphate should be clear. It is Na3PO4 because sodium is having +1 as the valency, and PO4 is having a charge of 3 minus. So cross multiplication will give Na3PO4. Now moving on with the uses of bases. First one, it can be used in antacids such as magnesium hydroxide and calcium hydroxide. Calcium hydroxide can also be a component of lime water, which is a laboratory reagent. We have studied it in the first chapter of chemistry. Next is NaOH, which is known as caustic soda, which is used for the manufacture of soaps. So now let us talk about the process of dilution. What is dilution? Dilution is the process in which when water is added to an acid or base, it results in the decrease of the concentration of H plus or OH minus ions per unit volume. This process is called as dilution. What does it mean? So let us take a container. Suppose in this container there was some acid. So I'm going to take unit volume of this acid. So it's better I will take a cube, and in this cube I'm going to take a unit cube. Unit cube means the cube which is having 1 centimeter in length, 1 centimeter breadth, and 1 centimeter height. So this is a unit cube. So initially there will be some amount of acids which will be present in this unit volume, and in that acid there will be high amount of H plus ions. To this acid which is having high amount of H plus ions, I am going to add water. So when water is added into this container which is having high concentration of H plus ions, what happens is now the container have both acid as well as the water, right? So now what happens is that per unit volume, how much H plus ion was there, that will start decreasing, and the concentration of the solution will start increasing. That is the amount of solution, not the concentration, but the amount of the solution that is present, that starts increasing, and the concentration of H plus in unit volume, that will start decreasing. However, the concentration of H plus ions in the overall solution, that does not change. So that is the important point to note. because the H plus ions, whichever H plus ions were there initially, that will be there in the solution also, but it will be scattered here and there, so that the number of H plus ions per unit volume is going to be lesser in the second case, that is after dilution. Now, whenever we are doing the process of dilution, that is whenever we are adding water into acids or base, what happens is it is an exothermic process. That means there will be generation of heat. So we have to be very careful while adding water to an acid or a base, because what happens is that sometimes it can release a large amount of heat, so in such a large amount, so that it can cause the mixture to burst, and it can cause severe injuries to our face as well as to our body. So we have to be extremely careful while doing the mixing or the process of dilution, especially with the concentrated sulfuric acid as well as concentrated nitric acid. So this is the points which we have to study related to dilution. Dilution is the process of adding water into acid or base in simplest term, and that results in the decrease in the concentration of H plus ions per unit volume. So this per unit volume is the most important concept. Now let us talk about the third topic of this chapter, that is indicators. So what are indicators? We have studied in the lower classes regarding litmus paper, right? So litmus paper can be used to distinguish between an acid as well as a base, because litmus paper turns the red litmus to blue if it is a base, and acids can turn the blue litmus to red. So this is what we have studied in our lower grades. So such substances which can give different color in acidic and basic medium and help to differentiate between the two types, that is acids and bases, is called as an indicator. There are two types of indicators. The first one is known as natural indicator, and the second one is known as synthetic or artificial indicators. Examples for natural indicators includes turmeric, China rose, and litmus. So first one is litmus. Litmus is extracted from lichens. Now, this litmus can change the blue litmus to red if it is an acid, and red litmus changes to blue in the presence of a base. Second one is the turmeric. Turmeric is extracted from curcuma conga, and that is converting the yellow color of the turmeric into red color in the presence of a base. That means if there was some stain in the yellow colored clothes, then what happens is if you are rubbing some turmeric onto it, what happens is that the color will changes to red. That means if you had some turmeric stain, if there was some turmeric stain on a piece of cloth and you are applying some soap onto that region, then what happens is that the color of this turmeric stain will now changes to red. Initially it was yellow and now it changes to red. So that shows that this is an indicator which indicates the presence of a base. So it can only be used to change the color when a base is present over there. Next is the case of China rose. So in the case of China rose, we are taking some China rose petals and we are placing them in water. So now when we are putting some drops of acid, it changes its color to brown, and if you are putting some drops of base, then it changes its color to green. Talking about the artificial indicators, first one is phenolphthalein. Phenolphthalein will become colorless in the presence of acid, and it will changes to pink when it is reacting with base. Next one is the methyl orange. Methyl orange changes its color from red to orange when we are putting some acid, and if we are putting some base, there is no change happening. Now there is universal indicator, which is used to measure the pH values between 3 to 11. So now let us study what is pH. We have a scale for measuring pH, that is known as pH scale. pH scale is a scale which is used for measuring the hydrogen ion concentration of the solution. And what is the full form of pH? pH, the P stands for potence and H stands for hydrogen. So potence hydrogen, what does it mean? The amount of H plus ions which are present in a particular solution, that is known as pH. And pH is denoted by, the equation for pH is negative log concentration of H plus. Now what is this logarithm? We will study in detail in class 11th. If the pH value is 7, then we say that that particular solution is neutral, and if it is greater than 7, then the solution is basic, and if it is less than 7, then the concentration is acidic. That means in our stomach we have hydrochloric acid present, so our pH is between 1.8 to 2.4, whereas the pH of pure water is 7, whereas that of acidic rain is 6.8 because it have traces of acid present over it. If it is a strong base, then it have nearer to 14. If it is a weak base, then it will have nearer to 8. So it depends on different solution. And for finding this pH, we have pH papers which gives appropriate color with different pH. So based on the chart that is available, we can find out what is the pH of that particular solution, and we have such experiments in the higher classes as well as in class 10 also. So now let us study the importance of pH. Why is this pH very important in our day-to-day life? First one is because our optimum pH is between 7.35 to 7.45. That means our blood pH is basically basic. Now why is it basic? It is because of the buffer solution which is formed due to carbonate and carbon dioxide. HCO3 minus is present in our blood, that is responsible for the buffering action of our blood. The carbon dioxide can react with water and it will form bicarbonate ions. This equilibrium is important for maintenance of the buffer in our blood. Second application is related to the acid rain. So when the pH of the rainwater is less than 5.6, sometimes it can become too acidic. In that particular case, it is known as acidic rain. Normal case, the rainwater is having a pH of 6.8. So when it is turning acidic, then its pH is 5.6. Rainwater becomes acidic because of the pollutants such as SO2, CO2, NO2, etc. And all these are acidic oxides because they are non-metallic oxides. And they react with water to form carbonic acid, sulfuric acid as well as nitric acid. So these acids, when it is falling on monuments, especially made up of marble, then that can cause damage to the buildings and monuments. The example is Taj Mahal. Next, pH in our digestive system. So if there is excessive production of hydrochloric acid in our stomach, then that can result in a condition which is known as acidity. Acidity can lead to pain as well as irritation, and prolonged acidity can lead to ulcers. So this can be prevented by using antacids. Antacids are substances which are bases, and these bases can neutralize the effect of acids in our stomach and thereby curing the pain and irritation. Example of an antacid is milk of magnesia, in which the major component is magnesium hydroxide. Next is the pH of the soil. Sometimes what happens is that the excessive use of fertilizers, especially after the Green Revolution, have resulted in making the soil acidic. So if the soil is too acidic, what happens is that the plants cannot grow. Similarly, if the soil is too basic also, the plants cannot grow. So if the soil is too acidic, then we will be adding quicklime to it. Quicklime is CaO, or we can also add slaked lime, that is CaOH twice. So these substances are basic, so they can neutralize the effect of acids in the soil. If the soil is too basic, then what will we add? We will be adding acidic fertilizers so as to neutralize the process. If base is more, we will add acids, and if acid is more, we will be adding bases. Next is the pH change as a cause of tooth decay. Now tooth decay starts, or it happens when the pH is lesser than 5.5. Now how does the pH in our mouth becomes less than 5.5? It is due to the acid producing microbes which are present inside our mouth. Now, when the pH is less than 5.5, what happens is that our enamel, which is the outermost covering of our tooth, which is made up of calcium phosphate, that gets corroded, and this corrosion will result in tooth decay. Next is the self-defense by animals and plants through chemical warfare. So in the case of ant sting or bee sting, we know that it consists of formic acid, which is HCOOH. There's a formula for formic acid. So these acids which are present in different animals as well as plants, they can cause pain and irritation to the animals, other animals like humans. So to avoid the effect of such acids, we have to apply baking soda, or even we can apply strong soaps to prevent the pain and irritation, or to reduce the pain and irritation. Now let us talk about the last topic of this chapter, which is salts. Salt is basically an ionic compound which dissociate to give an an acid cation as well as a basic anion. Now what does it mean? It is going to give us a positive ion other than H plus, and it is also going to give us a negative ion other than OH minus. So an example for a salt is our sodium chloride, which is the table salt, and this sodium chloride upon dissociation will give us Na plus and Cl minus. So here we cannot see H plus, here we cannot see OH minus, because during the process of neutralization the water molecule have eliminated out by the combination of H plus and OH minus from the solution. So now this is how a salt is formed. Salt is formed when an acid reacts with base in a neutralization reaction. There are three types of salts. First one is a salt which is made by the combination of a strong acid and a strong base. Example, hydrochloric acid plus sodium hydroxide will give us sodium chloride. So that is a strong acid, strong base salt, and that will have a pH of 7. Now there are some salts which are prepared by the neutralization reaction of a strong acid like HCl with a weak base. So weak base includes ammonium hydroxide. So when we are reacting these two, that results in the formation of ammonium chloride. So ammonium chloride will be having a pH which is greater than 7. Sorry, it is less than 7. It is less than 7 because the acid is strong. So stronger the acid, the pH scale is going to move in this particular direction. If the base is stronger, then it is going to move in the right direction. So if strong base is taken and weak acid is taken, in that particular case, an example which we can take is strong base is NaOH and weak acid is CH3COOH, that is the acetic acid. So they will combine to give a salt, that is CH3COONA, that is known as sodium acetate. This sodium acetate is going to have a pH which is greater than 7 because the acid was weak as well as the base was strong. So these are the three different types of acids which are present. First one is the three types of salts which are present. First one is the salt of strong acid and strong base. Second was the salt of strong acid and weak base. And the third is the salt of strong base and weak acid. Now let us see some of the common salts which we use in our day-to-day life. First one is the sodium hydroxide, which is also known as caustic soda. Now what is the formula of caustic soda? Caustic soda is NaOH. So how is it prepared? It is prepared by using the chlor-alkali process. That means we are going to take an aqueous solution of NaCl. Aqueous solution of NaCl is also known as the brine solution. So when electricity is passed through this brine solution, it undergoes decomposition. Upon decomposition, it will give NaOH along with some byproducts, that is Cl2 and H2. But this process, that is chlor-alkali process, is a very important process because whatever byproducts are obtained, even they are extremely useful for humans. For example, the NaOH that is formed near the cathode, because electrolysis is happening, so there will be an electrode which is known as the cathode and another one is the anode. So the NaOH will be formed somewhere near to this cathode, and this NaOH can be used for degreasing metals, soaps and detergents, paper making and artificial fibers. Cl2, which is formed near the anode, can be used for the water treatment purposes in swimming pools as well as for the preparation of PFCs, CFCs and so on. PFC stands for polyvinyl chloride and CFC stands for chlorofluorocarbon, that is also known as phryons, which are responsible for ozone layer depletion. Hydrogen can be used for the preparation of fuels. Then it can also be used for the preparation of ammonia for fertilizers. Next is the mixture of hydrogen plus chlorine. This will react to give hydrogen chloride, which can be used for the preparation of cleaning steel and also medicines, cosmetics and ammonium chloride. Now the mixture of NaOH and Cl2 together, that will form a compound NaOCl. This is having a bleaching action because of the presence of nascent oxygen. Now what is the formula of bleaching powder? Bleaching powder is formed when CaOH twice, which is slaked lime, reacts with chlorine. So that will form a compound, that is CaOCl2, that is known as the bleaching powder. Now what are the uses of bleaching powder? First one is it is used in the bleaching of cotton and linen in textile industry. Second, it can be used as an oxidizing agent in chemical industries. And third, it can be also used for disinfection of water. Talking about the second salt, which is baking soda, the formula of baking soda is NaHCO3. Preparation, we can prepare it from NaCl by reaction with H2O, CO2 and NH3. It will give NH4Cl and NaHCO3, and the process is called as Solvay process. So details of Solvay process is a 4-step process which you will study in class 11th. Talking about the properties of baking soda, first one is known as decomposition. So when we are decomposing this particular compound, that is baking soda, it will release as sodium carbonate, water and carbon dioxide. Next, for making baking powder, it can also be used for making baking powder. That is one of the most important practical use of baking soda. Now what happens is that this baking powder, so when we are making the baking powder, what happens is that this baking soda, that will undergo decomposition and it will release as carbon dioxide. This carbon dioxide will come out from this cake or bread in the form of bubbles, and due to the evolution of these bubbles, the cake dough or the bread dough, that becomes extremely soft and fluffy. So that is responsible for the fluffy nature of the cakes or the bread. So that is why it is used for making baking powder. So that is explained by this particular decomposition equation. It can also be used as an antacid. So for that we are going to react it with an acid. So when it is taken in as an antacid, what happens is that it will react with the hydrochloric acid which is present in our stomach, and it will neutralizes the acid. As a result, it will form salts, water and carbon dioxide. It can also be used as a soda fire extinguisher. So these are the various uses of baking soda. Once again, the preparation of baking soda is from NaCl by Solvay process. Decomposition gives CO2 gas, that is why it is used as baking powder. It can also be used as an antacid because it's a base, so it can neutralize the effect of the acids in our stomach, and it can also be used as a fire extinguisher. Next is the washing soda. Washing soda is having a formula of Na2CO3.10H2O. It is prepared when sodium carbonate is reacting with water. So it results in the formation of Na2CO3.10H2O. It can be used in glass, soap as well as paper industries, and it can also be used in the preparation of sodium compounds such as borax. It can be used for the removal of permanent hardness of water also. This is a question in this year's sample paper, so this is important. Washing soda is used for removal of permanent hardness of water. Next is the plaster of Paris. So what is plaster of Paris? It is having a formula of CaSO4.12H2O. Now, how is it prepared? It is prepared from another substance which is known as gypsum. Gypsum is having a formula of CaSO4.2H2O. So when we are heating the CaSO4.2H2O, that is gypsum, 1.5 molecule of water is eliminated out from each molecule of gypsum, and that results in the formation of CaSO4.12H2O. Now this plaster of Paris is a white powder, and hence when it is mixed with water, what happens is that it will again form gypsum back. So it is used for curing fractures, and also it is used for the preparation of toys as well as decoration material. Now here you can see some molecule of water which is associated with the formula. This amount of water is known as the water of crystallization. So in plaster of Paris, the water of crystallization is half. In that of gypsum is 2. And what about the washing soda? It is 10. So that is how we calculate the water of crystallization. So with this, we come to a conclusion of this chapter, that is acids, bases and salts. This is a pretty small chapter which dealt with acids, bases, salts as well as some important salts in our day-to-day life. So see you again in the next lecture. Till then, goodbye and happy learning.